Okay, so I think one of the most important things that we're going to need to be able to do in a lot of problem solving for chemistry and any physical science is the idea of dimensional analysis, or simply using units and conversion factors to help us solve problems. Okay? Now, what do we mean by using units to help us solve problems? Well, when we do a calculation, we also have to consider what that arithmetic does for our units. Okay, we saw a couple of examples. If we add 1 centimeter plus 2 centimeters, okay, we know that the units are centimeters sum. Okay, if we multiply, if we're looking, say, an area of a space, 1 centimeter times 2 centimeters, our units multiply as well. So 1 times 2 is 2, and of course centimeter times a centimeter is centimeters squared units for area. Now what happens if we divide units? So 1 centimeter divided by 2 centimeters turns out to be 0.5, and that's it. The centimeters cancel. Okay, now it's a little bit easier to see if you were to rewrite that division problem as a factorial. So 1 centimeter over 2 centimeters, we can see that the centimeters cancel to give us 1/2, or 0.5. Okay, the idea that centimeters cancel out shouldn't come as a surprise, because any value, the same value over each other, cancel out to equal 1. Just like 9 over 9 equals 1, a centimeter over a centimeter, it's the same thing, equality equals 1. Okay? So what we're going to do is we're going to use equalities to set up conversion factors and let the units sort of lead us to the right answer. So the easiest or the simplest way to use conversion factors would be just converting one set of units for a single measurement to another units within the same measurement, such as converting 1.5 inches to centimeters. Okay, now to do so we have to know the equality. Now the equality for inch to a centimeter is 1 inch equals 2.54 centimeters. Okay, now that is an equality, just like 9 equals 9 equals 9 equals 9 and 9 over 9 equals 1. We can set up, from one equality, we can set up two conversion factors. Okay, we can say that there are 2.54 centimeters per 1 inch, or in 1 inch, we've got 2.54 centimeters. Okay, now these are conversion factors, the ratio of an equality. So from one equality, we can always write two conversion factors. Okay, what dimensional analysis is going to enable us to do is we're going to use conversion factors to get to final answers, and they sort of give us a conceptual game plan or roadmap to solving such problems. Okay, so one of the first things we do, or I like to do, is when I'm solving a problem, I like to write down what the units are for my final answer. I almost crossed it out, but we're looking for the amount of centimeters in 1.5 inches. So if I write down my final units first, that will help me get there. Okay, I'm going to start with 1.5 centimeters, excuse me, inches. And convert that to centimeters. So what I'm going to do is I'm going to multiply it by the conversion factor that will cancel out inches and produce centimeters. So I've got two conversion factors, A or B. Okay, I'm going to use conversion factor A. because inches are on bottom, centimeters on top, and that will do what I need to happen. 2.5 centimeters over 1 inch. Okay. Just like 9 over 9 cancels, centimeter over cents, 1 inch over 1 inch cancels out. So 1.54, or excuse me, 1.5 times 2.54 centimeters equals 3.81 centimeters. Okay. Now, if you have trouble visualizing why inches cancel out, I wrote it as a, this conversion factor times 1.5 inches, but this is all one big problem. Everything on top we multiply, everything on bottom we divide. So 1.5 inches times 2.54 centimeters divided by 1 inch. Okay. Now, let's think about significant figures. We can see that this measured value, 1.5 inches, has two significant figures. It turns out that 2.5 centimeters per inch is an exact number, so we don't have to worry about significant figures for that. But anyways, if it wasn't an exact number, it looks like 3 sig figs, so we're going to have to go with two significant figures, so we should turn this into 3.8 centimeters as our final answer. Okay, so let's do another example of using conversion factors as a roadmap through units to get our final answer, which is known as dimensional analysis. Okay, I want to convert 12.5 feet to meters. So what was the first thing I did? I'm going to write down the units for my final answer, meters. Okay, now I am going to need a conversion factor from feet to meters. The problem is I don't know one offhand. Of course, we could look one up, save us a little bit of trouble, but instead of doing that, I know that I can also use, instead of one conversion factor at a time, I can use multiple conversion factors to solve problems. So I know offhand that in 1 foot there are 12 inches. And I know that in 1 inch, we just learned last problem, there are 2.54 centimeters. And then even going further, we learned for our prefix multipliers that there are 100 centimeters and 1 meter. Okay, from each of these equalities, I can build two conversion factors, right? So 1 foot over 2 inches, or 12 equals 12 inches. So I can say that in 1 foot, there's 12 inches, or there are 12 inches in 1 foot. Both of these say the same thing, that 1 foot equals 12 inches. Now I can do the same, write two conversion factors for 10 to the second centimeters over 1 meter, or 1 meter over 10 to the second centimeters. Same thing for our inches and centimeter conversion factors. So this time I'm just going to use a couple of conversion factors to convert feet to meters. So the first thing I'm going to do is I'm going to convert feet to inches using one of these conversion factors, inches to centimeters using conversion factor I get from that equality, and then finally centimeters to meters. Okay. Sometimes this is helpful to sort of come up with a game plan or a conceptual plan of solving problems before you even write any numbers down on the paper or throw anything into your calculator. Okay. So to convert feet to inches, I'm going to need to cancel out feet and convert to inches. So I'm going to use this conversion factor. In 1 foot, there are 12 inches. That way my feet cancel out. Okay, now I'm going to go from inches to centimeters, so I'm going to want inches on the bottom, centimeters on top, so that inches cancel out. 1 inch, 2.54 centimeters. Okay, what am I doing? I converted to inches, now I converted to centimeters right there. So I've got one last conversion factor to build out of that equality. What am I going to want on the bottom? I'm going to want centimeters on the bottom, so there's 100 centimeters in 1 meter. Centimeters cancel out, so my final unit is meter. Okay. Before I throw anything into my calculator, I just make sure that units cancel out to give me the units that I needed, meters, for my final answer. Okay? If I didn't set up my conversion factors properly, I wouldn't get my proper units, and that would give me an indication that I've done something wrong. So before I even throw anything into the calculator, I check to make sure my units match up, and that's really the power of dimensional analysis. Okay, so I throw this in my calculator. Everything on top I multiply, everything on the bottom I divide. 12.5 times 12 divided by 1 gives you the same thing, so usually I leave those out. 12.5 times 12 times 2.54 divided by 100, 10 to the second, it's going to give me 3.81 meters. Okay, this time, how many significant figures should I have? Well, in my only measured value, I have 3 significant figures. Again, all of these equalities are not from measured values. These are exact numbers, so their significant figures don't really matter to us. So I should report my final answer to 3 significant figures, which I have. So I'm good.